Hello guys, welcome to the video. So in this one we're gonna make something complicated, and to be honest I had to twist my brain a little bit to make the feature we're going to make in this video. And what I'm trying to say is that it is pretty complicated, so if you are very new to Unity, please don't get discouraged by things we're going to be doing in this video. I understand they can be confusing, but there is no really easier way to do things that I want to do in this video, and I honestly feel like it's a bit early for stuff like this, but I want to show you how to make this effect, and I think there is no better place for it because we're working on a crossbow tower, and this effect is needed for crossbow tower. So check this out. When a crossbow tower shoots, we have this laser on the crossbow, and we can see it shines up. When it's ready to shoot, then it's sort of stop glowing. You can see it's not glowing at all, and then it's gonna start glowing again once weapon is ready to shoot again. It's gonna glow up with the time. And the main point is not only just to make it glow up like that, it should be done during the cooldown of the attack. So that's what we're gonna do in this video. And as I said before, it is a little bit complicated, so it might feel a little bit confusing. I understand that. Just try to power through this one, and with the time, there is no doubt it will be easier to understand. Alright? So let's begin. We have this crossbow visuals script. We need to open this script, and then in this script we need to get reference to the mesh renderer that has material with the emission effect on it. So maybe let's make serialize field private mesh renderer. I'm gonna call it just let's call it just mesh renderer for now. Why not? And then let's go back to Unity. So over here we have the crossbow emission part 2, which is responsible for glowing effect, right? And it has a material of emission blue, and this is the mesh renderer component. So what we need is to get access to this mesh renderer component, then get material of this component, and then we need to change emission over here. To be precise, we need to change intensity with the time, but we cannot do it simply like that, just by typing mesh renderer.material.emission.intensity. It doesn't work like that. It's a bit more complicated than that. And first I want to explain about materials. So even if you change material in a play mode, over here, for example, we are in the play mode and I'm going to change something. Let's say this one is 147. I'll remember that and I'll do 0. It becomes blue like that, and even if I go out of a play mode, it's still gonna be blue like that. More to that, you can see it's not only blue on a crossbow, it is also blue over here, because this one uses the same material. And the problem here is that we're not only changing things out of a play mode, we're changing things for the material all across the game, and that essentially affects the visuals for all of the objects in the game that use the same material. So first of all, let me revert the changes. So first of all, to work with the material, we need to make new instance of a same material, and then we need to take same mesh renderer and make its material equals to new instance of a material. Sounds confusing, I know. Let's just do it and you'll see what I mean. Sorry, let's take this crossbow mission part, drag it into this field. Let's go to the script. Maybe I'll make a header for glowing visuals or something like that. Then we're gonna make a reference to the material, and I'm gonna make it visible for now. Material, just that. Then we're gonna do material equals to new material. So we're going to make new instance of a material, and then in the parentheses we can give it a source, so it will create a temporary material by copying all properties from another material, just as you can see written on the screen over here. So as a reference we're going to give it mesh renderer dot material. Okay, now let's save it. Let's go back to Unity and see what we have. So we can see we've got over here emission blue instance, which is a new instance of the same material. Now we can go back to the script and type mesh renderer dot material equals to material. And this essentially will take mesh renderer's material and make it equals to newly created instance of the original material. So let's save it. Let's go back. Let's go to play mode. And we have emission blue instance. Then we can go to emission part over here. And we can see we have material on it. And it's not original, it's the instance. And I can change the instance as I like. You can see it is not affecting cubes or robots over here. It is only affecting the crossbow itself. And also if I do some changes over here, for example, make it like this and go out of a play mode, it will not be saved. And when we start a new game, it's going to be back to original. And now we can take the emission material on this mesh renderer and change this color during some period of time. Now we need to learn how to change something during period of time. How to do it, for example, during 2 seconds or something like that. Well, it's not that easy, but I'll try to explain it as much as I can. Okay, let's make a public boolean can speak, maybe just that, just for example. Then we're gonna go over here and I'm gonna make a new coroutine. Let's do private enumerator and I'm gonna name it maybe as change emission, like that. Emission, yes. And inside of this coroutine, we need to do something else. Before we did pause coroutine for float value for some amount of seconds, right? Now we're gonna pause coroutine until the next frame. That's what we're going to do. And this will help us to stretch some functionality during some period of time. Here is the example. Let's do while can speak. We're gonna do debug log. Current frame number equals to, and then plus time frame count. Okay. And then over here, we're going to type yield, return null. And after that, we're going to do debug log, cannot speak anymore. Okay. Just like that. So, and let's start this coroutine in the awake, and then I'm going to explain what we did. Start coroutine, change emission. Okay. So we did start a coroutine over here. Pay attention to this. Don't forget to do it. Then let's go to this coroutine and talk about this a little bit. First of all, what is while? We didn't use it before in this course. While allows you to do something while conditions in these parentheses are met. So while can speak is true, we can debug this message. If this one will become false, we're gonna exit the while loop and we're gonna go to the next line of code. But until we are inside of a while loop, we sort of trapped in the while loop, and program cannot exit the while loop until these conditions are met over here. So essentially, we start in a coroutine, and while this boolean is true, we will not be able to do anything over here because we are inside of a while loop. Now, the next thing is we debug in a message. This is simple, and time frame count gives you the frame number since the start of the game. And then over here we did write yield return null. Yield return null pauses the functionality until the next frame. And because of that, because we use it like that, it allows us to stretch functionality during some some period. In our case, the duration of this period will be controlled by me disabling the boolean in the inspector. But after that, I'm going to show you how to do it with a timer. As of now, I just want to explain that we are trapped inside of the while loop until conditions in the parentheses are met. And also, because we haven't this yield return null, we're going to wait for the next frame to do something. Okay, now let's save it. Let's go back to Unity and let's see it. I'm going to click can speak. I'm going to go to the console. Let's go to play mode. And we can see messages, current frame number and number of the frame. And you can see it's not just a number, it is 667, 668, 669, 670. Because we're using the yield return null, it exactly waits for the next frame to do something. Then at some point I decide to stop this, and I'm gonna uncheck can speak. And now we can see that we did see last frame, and then we saw a message cannot speak anymore because we did exit the while loop. Very nice. Now let's extend the functionality of this. Let's do something different here. Let's type over here float start time equals to time.time. In this way, we registering the start time of the moment this coroutine was called. That's the idea. We want to know when did we start the coroutine. Then we're going to have float duration, and let's say duration for now is going to be 3 seconds. All right. Then inside of this while condition, instead of having what we see right now, I'm going to type while time.time minus start time is less than duration. We're going to debug a message of a current frame, and we're going to just do nothing else for now. That's it. So if I'm not wrong, now we're going to see this information during 3 seconds since start of the game. And let's just see if it works. Then I'm going to explain what did I do over here, okay? Why we need it. Let's go back to Unity. Gonna clear this up. Let's go to play mode. And what we have is messages during 3 seconds, and then we can see cannot speak anymore. So why did it happen like this? What did we do? Well, we having starting time equals to time.time, which essentially registers the time we started this coroutine. Then over here, by using time.time minus start time, we checking how much of a time has passed since we did start the coroutine. We can leave a comment over here. And briefly, just as example, let's try to understand this. Let's say when I started a coroutine, it was 5 seconds in the game, okay? Now, 5 sec, let's say that. Then when while loop is called, we check. For example, time in the game at the moment is 6 minus 5 equals to 1. And obviously 1 is less than 3. Since it works like that, since 1 is less than 3, since this is less than duration, then we can proceed and do something inside of a while loop. And we did just debug the message number. Then we did wait for the next frame, and on the next frame we do check again. On the next frame it would be something like 6.5, for example, yeah? And we do minus 5, and that would be 1.5 value, which is still less than 3. Means we can enter while loop again. At some point, the value of a time.time, the current time in the game, will be, let's say 9. 9 minus 5 is 4. And 4 is not less than 3. And if that's the case, then it's going to exit the while loop and proceed further. So this is how you do something during some period of time. Now, instead of having local variable for duration, let's pass duration through parentheses, float duration, okay? Just that, because we're going to use this method for something else, not for just debugging messages. Now let's go a little bit up. Let's comment this line of code. And let me explain something else before we continue, because this is very important. We know how to do something during period of time. For example, we did debug message for a period of time. Now we need to affect material that we have on a mesh renderer. Let's go to play mode. I'm going to open the material. And yeah, this was the material. I'm sorry. This is the one. So over here, we need to affect this emission map. We need to change color, and we need to have intensity for this color to make it glow as we want. We need to have a maximum value for that because we don't want it to look ugly like this. And also you should know that we cannot directly change this intensity over here. Instead, we would have to do something else, and I'm going to show you what we're going to do right now. Okay, let's go to the visuals over here. Let's go all the way up. I'm going to remove this, and we need serialize field, private float, and it's going to be sort of a current power, current glow effect. Let's use intensity. Let's do current intensity, and we need serialized field, private float, max intensity. Maybe let's take those two lines of code, move them here and add a space so it's a bit easier to recognize in the inspector. And also let's make this value equals to 150. As I mentioned before, we're not gonna modify intensity directly on that graph over there. Wait a second. Let me take any material. Yeah, so we cannot directly change intensity over here. We need to find the intensity we want, then we need to make the color, then we need to convert the color into gamma space, and then we need to apply that color to the material. It's a bit more complicated than just changing intensity over here. So that's why we're going to have such a big value as 150. But still, it's going to be very easy to control, so don't worry about that. Okay, now let's go to the coroutine we have over here. And first of all, let's make a float. Maybe something like start intensity, and it's going to be equals to 0, because we want to start from 0 when we increase in the value. We want it to be like not glowing at all and then glow up with the time. So 0 over here. Then inside of this while loop, we're gonna make current intensity equals to mathf.lerp. And before, I did explain how lerp is working, but just in case, I'm gonna say that lerp is essentially getting you a percentage value between point A and point B. In our case, we want to get start intensity as a point A, and as a point B, we want to have max intensity. And as for T, we're gonna do something special here. Let's just type it and I'm going to explain it, okay? Let's type float t value equals to time.time minus start time divided by duration. And then let's type t value over here. All right, so the idea is that current intensity will be equals to current lerp value we have, and lerp value will be between 0 and max intensity, right? 0 is defined over here, and max intensity is defined over there in the inspector. And t value is essentially a percentage of the value between these two. If start intensity is 0 and max value is 150, having t value of 0.5 would return 75. Yeah, that's what lerp does. And because we do it every frame, we interpolate the value from minimum to maximum during the duration we have over here. Okay, so now what is a t value? This formula over here essentially calculates the proportion of the duration that has elapsed since the start of the coroutine. Maybe I should leave a comment for that. Give me a sec. Yeah, and let me explain how do we calculate it just on some example. I'm gonna open calculator, and let's say starting time that we called the coroutine was, I don't know, 12 seconds in the game. So it was 12 seconds since the start of the game. It is the starting time of the coroutine. Then let's say we do this check in this while loop when time in the game is 12.2. Okay, then we do minus start time and we get in 0.2. Then we get in this value and we divide in this value by the duration we have. Let's say we're going to divide it by 3. Let's say this is our duration, and we get in 0.06. So if not that much of a time has passed since coroutine was started, this value, t value, will be very low. And in that case, the current intensity will be equals to some very small value, because this is the lerp value over here, 0.6. Then let's try this again, but let's say we are in 14.5 time in the game. And we're gonna do minus start time, which was 12, we get in 2.5 divided by 3, and it is 0.83. And in that case, the lerp value would be somewhere here, and this would current intensity would be equals to. Okay, so essentially, the more time has passed, the bigger value is. And that means the more time has passed, the bigger current intensity gets. That's the idea. Now, I think we can visually see the changes just by starting this coroutine. Let's go to the awake. Let's start a coroutine, and let's use 3 seconds as a duration. I'm gonna save it. Let's go back to Unity. We have max intensity 150, current intensity 0, and if I go to play mode, this value is supposed to grow up to 150 during 3 seconds. Okay, this is what it does. It works very well. And now we can see it is not exactly the maximum value, it is almost the maximum value. So we have to snap it to the max after the while loop over here. Let's do current intensity equals to max intensity, just like that. All right, we did a pretty big chunk of work we have to do for this mechanic, and I want to break this video into parts. So this would be the part 1, and part 2 will be just in the next video. I'll see you there.